the introduction, proper rock fragmentation is the first key element of the ore reading process. So fragmentation in mining, fragmentation is very necessary. If you get a good fragmentation, it's part of the way that you can be able to um, recover your ore the way that you want it. Okay. But if the fragmentation is poor, sometimes you need secondary blasting. For instance, when you have boulders, after the blasting, after the primary blasting, now you have tools and do all those stuffs. So we want good fragmentation. Carefully designed blasting will be an even important aspect of successful surface mining in the future as pits become deeper and steeper. So we know that in open pit mine, as you mine, the pits become deeper and the walls become steeper. Okay. So um carefully designing the blasting operation is very paramount. Quality separation becomes paramount in order to avoid dilution and ore losses during the blasting operation. So if you have ore, in the pit, so the way you blast that particular formation can influence the recovery of the ore. All right. Okay, so let me use this figure here, for instance. So assuming, I hope you can all see the screen, this figure. Can you all see it? For this particular figure, this is a bench where you want to blast. So from here, you can see the holes. So the circles there are the holes. Okay, so these are the holes. So this is what we call a pattern, a drill pattern. So a pattern is just a collection of drill holes to be blasted. Okay, just a collection of drill holes to be blasted. Is what we call a pattern. So this is a pattern to be blasted. This is a pattern to be blasted. So assuming there is ore here, right? If there is ore in that particular pattern, the way that you blast it should be different from when there is no ore. Okay. If there is ore, the geologists can influence the decision. They might tell you that this, because if you use any type of tie up, we'll be talking about tie up when we start with the software. So if you don't know tie up, don't um, confuse yourself. I'll explain it further for you. So the tie up will influence how you can recover the ore for this particular pattern. If there is ore, there are different types of tie up. Tie up is simply how you arrange the delay during the blasting process. So maybe this hole should go first after this hole goes first, followed by the next hole. Then yes, so that's the tie up. How you control the delay, how you um the depiction of the direction of throw. Okay, the direction of throw when you are blasting that particular pattern. So if there is an ore, you have you have to influence the decision making because there's an ore. You cannot blast it in a way or in a similar manner as compared to when you have only waste. Okay, when you have waste, that one you can just blast it because it's only waste. You don't have, you don't care about whether there will be dilution or something. This all waste, so you just blast it anyhow. But when there is ore, you have to blast it in such a way that the ore will be lost. Some of the ore won't be lost into the waste. Okay, that's why we term as the dilution. The dilution. So the objective of this course is to design a blast for a surface mine, taking into account the various parameters that influence the design, including the environmental consideration. So during tie-up and blast design, they consider the parameters, okay, which we'll be talking about today, and also they'll consider the environmental impact. So um, they run the simulation and see when I say the environmental impact, I'm talking about the side effects. So the PPV, that is the blast induced gun vibration, and also air blast. So those two parameters, environmental parameters, are very significant. So as you design your parting and your tie-up, you have to make sure the impact is not huge enough to exceed the threshold. We know that, okay, let me tell you, from the LI, okay, the mining regulation, the PPV threshold is 2 millimeters per second. And for air blast, the threshold is 117 decibel. Okay, 117 decibel. That is it for the air blast and the PPV. So these are the threshold that should not be exceeded for any pattern that is blasted. These are the threshold from the mining laws. So if you design a blast and the PPV threshold exceeds the PPV that is recorded for that particular blast exceed the environmental threshold, you have to redesign and make sure it falls within the threshold, because we can stop the mine, we can halt the operation of the mine if you don't follow the procedures, the mining regulations. Okay, so these are the environmental consideration that's millimeters per second. Okay. Okay. So these are the environmental threshold that you have to look at. So the remaining parameters are here, the blasting parameters. All right. So for the blasting parameters, there are two major types. Okay. The blasting parameters. We have those that we cannot control. Those that we cannot control. Right. So for instance, the geology of the formation, you cannot control that one. I hope we are all aware of that. You cannot control the geology of the formation. Um, the rock characteristics, you cannot control them. Can we control these ones? So these ones are uncontrollable. And we have ones that we can control. We have ones that we can control. So based on our design, we can control those ones, like the bedding that you use, the spacing, the stemming, all those stuff, we can control them. So we have the uncontrollable ones that we are aware of that. We have the controllable ones. So the controllable ones, we have the hole diameter. So the hole diameter will depend on the bit, the drill bits that you'll be using, the bit diameter. If you are using 165 millimeters diameter, that means the whole diameter will be 165. If you are using 115, that will depict your whole diameter. Okay. The whole depth. The whole depth also depend on the rod. The maximum depth that your drill can draw, it will depict the whole depth. Also, all those are controllable ones, right? You can control them, because whole diameter, you can choose to use 115. You can choose to use 115 diameter bit. Okay. And you can also choose to use 165. So that means you can control the whole diameter. The same applies to the depth. You can use a draw that can draw 10 meters. You can use a draw that can draw up to just 6 meters. So that one too is controllable. You can control it. We have subgrade drilling. Subgrade simply means sub-draw. I will talk more about it. Sub-draw. That one too, you can control the depth of sub-draw that you want. Stemming. Stemming, you can control. So all those parameters here, we can control them. And I know from the previous courses, you are already familiar with um, the terminologies, right? Hope you are familiar with them already.
Yes.
Okay.
Hello,
Yes, so I know you are already familiar with them. I know you're already familiar with them.
hello, hello,
Yes, so um,
hello.
this is just uh, a revision of what you have already learned. Okay. I know you have already heard about them, but since you'll be using it in the software, that's why I want us to take it more seriously. Because if you don't understand those parameters, yeah, and we are using the software, you'll be confused. Okay, so if you don't get it, if you didn't get it, make sure you get it now, right? So if you have a bench like this one, you have a
Hello.
bench
You have
that um, you want to blast. So these are the parameters